This next video in the 5.6 series is very similar to what we just did. So we looked at population growth that was growing exponentially continuously, and now we're going to look at money compounding continuously or growing exponentially naturally continuously. Okay, so what we're going to use is the exact same formula. So P of t is equal to P naught times e to the kt. Right? Same growth function. But this time we're going to define P of t as the amount of money in your account after t years, P naught being your initial amount invested or your principal amount, K being your interest rate that you're compounding continuously at, and then T being again time in years. So let's look at this first example. It says, suppose that $2,000 is invested at interest rate K, compounded continuously. So that shows us that we are using a base E, but we're not going to use any other base. And it grows to $2,504.65 after 5 years. All right, let's start with my equation. P of t is equal to P naught E to the KT. It'd be a good idea to pause your video right now and see if you could put these values into the equation where they would go. So hopefully you did. So the amount after time t is that $2,504.65. Your initial amount is the $2,000. And then E, we don't know K. And then T is going to be 5 years. All right, what type of equation is this? Where's the variable? The variable is in the exponent, so this is an exponential equation. To solve an exponential equation, you want to isolate your power so that you can take the log of both sides or change to logarithmic form. So pause the video and give this one a solve. Step number 1, divide both sides by 2,000. We've got $2,504.65 divided by 2,000 equal to e to the 5k. Now at this point I can take the log of both sides. I recommend taking log base e, and then I can use the power rule to bring my exponent down, or I can simply change this to logarithmic form. So I could say 5k is equal to log base e of $2,504.65 over 2,000. Right? The other option was take the log of both sides, so the log of $2,504.65 divided by 2,000 equals the log of e to the 5k. And again, like I said, I recommend taking log base e. So now when you apply your power rule, we have ln of $2,504.65 divided by 2,000 equal to 5t times log base e of e, which is 1. So now to solve for, sorry, not t, k. Same deal. So now to get k, we're going to divide by 5. So it's going to be the ln of $2,504.65 divided by 2,000, all divided by 5. All right, plugging this in my calculator, I get the ln of bracket $2,504.65 divided by 2,000, unbracket, oops, I put 200, 2,000, all divided by 5. That gives me 0.0450000364. The answer to this question would be k equals, I'm going to times this by 100, so I would say the population, or the growth constant, or my interest rate, there we go, is 4.5%. But if I'm going to use this number again, the reason I've written it all out is that you're never allowed to input a rounded answer into another step, because if you round differently than someone else, you're going to get a different answer. So the rule in math is you just use unrounded all the way. Since we know we're going to use this number again, and where, I'll show you where. So we've got P of t is equal to 2,000 e to the 0.0450000364 t. It gets really tiring to write that. Because your mathematicians always use these unrounded answers, your calculators have compensated for it by allowing you to store things in its brain. So what we do is we can store this. So if you have the right type of calculator, you can hit STO, and then you can store it as any of your letters that are written above your button. So mine are written in blue. So I'm going to store mine as A. So I can clear my calculator, I can do other calculations, and when I want that number, I can recall it back. Another option is that you have an answer button. So this is an answer. So if you're going to use that number in the next calculation, you can know that this is the answer on the last line, and you can input the answer in here. So in other words, when we plug this into another calculation, we can use the answer from the previous line, or we can have this stored value of A. Because now in question C, it says, well, how much do you have in your account after 10 years? So we're going to put in a t value of 10. So 2,000 times e to the 0.045. Can't do fours. 45. There we go. 0.00364t, which is now 10, sorry. And I'm going to, in here, I'm going to recall A, or I'm going to hit alpha answer when I type it in. So to type this in, I'm going to go 2,000 times e to the bracket. Now I'm going to hit recall A. Maybe you hit alpha answer. Maybe you just type in the decimals you see it. It does not matter. Times 10 on bracket equals. And I get, after 10 years, that I have $3,136.64. All right, last bit of this one. After how long will the $2,000 have doubled? Again, you could put $4,000 in for P of t and then solve the equation, or you can use the shortcut. We are finding doubling time. So that's going to equal ln 2 over k. So it's going to be ln 2 over that huge decimal, 0.045000364, or simply A. I often just put like a little A in the thing because I remember that I've stored it as that. And so then I'm going to type in ln 2 divided by recall A equals, and I get 15.4 years. All right, I only gave you one question to practice in this because it's very similar to population growth, but it is a good idea to practice.